Hello everyone, it's me again, Mom Princess, and I'm going to discuss another topic about science, and that is about quantum numbers. In this video, we're going to talk about the SPDF sublevels or orbitals, and you need to know that S orbital has spherical shape, P orbital has a dumbbell shape, D orbital has a clover leaf shape, and F orbital has an unusual shape and may vary. But also, as a reminder, something that you need to know that the number of the sub-energy levels is actually equal to the number of sublevels. So when n is 1, you only have one sublevel, and that is 1s. When your n is 2, you have two sublevels such as 2s and 2p. When n is 3, there are three sublevels such as 3s, 3p, and 3d. And if your n is 4, there are four sublevels such as 4s, 4p, 4d, 4f, and so on. So the S sublevels can actually hold up to 2 electrons only. So 1s2, 2s2, 3s2, and 4s2. While for the P sublevels, it can hold up to 6 electrons, but not more than 6 electrons. So it is 2p6, 3p6, and 4p6. While for the D orbital, it can hold up to 10 electrons, maximum of 10. So meaning to say it has 5 orbitals. So it is with a maximum of 10, so it is equivalent to 3d10, 4d10. And last but not the least, for the F sublevels, it can hold up to 14 electrons, meaning to say it has 7 orbitals. So 4F14. Maximum 14, but not more than 14. So do not forget this one. Okay, this is very, very important when you're dealing with quantum numbers. And before I forget, please bear in your mind that whenever you have the S sublevels, L is equal to 0. S is equal to 0. And then, if you have the P sublevels, L is equivalent to 1. If you have the D sublevels, L is equal to 2. And if you have the F sublevels, L is equal to 3. Do not forget these terms. Moving on. So you need to be familiar with these four quantum number, N, L, M, L, M, S. So if we talk about N, this is about the main energy level. L is the sublevel, which is associated with the SPDF orbitals. And then M sub L, that is classifying the orbitals. So meaning to say that if it is S, it has 1 orbital and has a value of 0. If it is P, it has 3 orbitals and has a value of between -1 to +1. So -1, 0, +1. If it is D orbitals, D sublevels, it has 5 orbitals. So this is between -2 to +2. So that is -2, -1, 0, +1, +2. And last, we have the F sublevels. So it has 7 orbitals, which varies from -3 to +3. So when it comes to orbital diagram, an up arrow has an equivalent spin of +1/2. And if it is a down arrow, it is equivalent to a spin of -1/2 electron. Okay? So don't be confused with these 4 terms for the quantum numbers. Next, let us have now our example in order for you to better understand this concept of quantum numbers. Actually, this is easy, so you just need to listen well. So let us have our example number 1, 3p5. The n here is 3. So you have 1, 2, 3 orbitals. And L, since P, you're talking about the P orbital, so it is equivalent, the L here is equivalent to 1. So it is ranging from -1 to +1. So N, I mean -1, 0, +1. So using this subscript 5, you can now draw an arrow. But do not forget that you need to finish all the arrow up to complete the orbitals here before you start doing the arrow moving downward. So if you have here 5, so you need to have 1 arrow up, 2 arrow up, 3 arrow up. Since you complete already the orbitals with the arrow going upward, that's the time that you can go back from the first orbital and do the arrow downward. So we have here 4 and we have here 5. So you have the 5 arrows here. So from that, the last arrow is moving downward. And therefore, it has the value of m sub L, which is 0. And what will be the spin or mean the ms for this given? Ms here, since it is moving downward, therefore the value for this is -1/2. Remember, I explained it a while ago. If it is going upward, that's +1/2. And if it is going downward, it is -1/2. So take this note again that you need to finish all the arrow up and then followed by the arrow downward. Okay? Example number 2, still the same. We have here 4d4. So our n here is 4. So you have here the orbital 1, 2, 3, 4. Then, since you have here the d orbital, therefore your L is equivalent to 2. Remember that S is 0, P is 1, D is 2, and F is 3. So do not forget that. Now, after that, you can already have the arrow. Oh, see, since you already have the L, which is ranging from -2 to +2, you can now draw the arrow. And you need to fill up all the orbitals of the arrow moving upward. So that is 4, so you have to count 1, 2, 3, 4. Okay? So afterwards, as you can see, that the arrow is pointing upward. Therefore, your ML stops up at +1, and your spin has a value of +1/2 since the arrow is moving upward. Okay, finish all the arrow up and then followed by the arrow down. It's easy, right? So let us have the third example. Let us have 5F13. So that's so many, I think. For our N, we have 5. So you have 1, 2, 3, 4, 5. For our L, since that is F, So that's equivalent to 3, ranging from -3 to +3. So that's the time that you can now have the arrow. It must be 13. So 1, 2, 3, 4, 5, 6, 7. Then, since you completed all the orbitals, you can now go back on the first orbital, and then you can have the arrow moving downward. So 8, 9, 10, 11, 12, 13. You stop at +2. So therefore, your ML is +2. And what will be the value of the spin there? MS. So we have here -1/2 since the last arrow is moving downward. Because according to Paul's exclusion principle, it states that no two electrons can have the same set of 4 quantum numbers. So bear that in your mind. See that these 4 quantum numbers are different when it comes to their electrons. So that's it. So let us have problem number 4 or example number 4. What if this is the case? 1s2, 2s2, 2p3. So according to Aufbau principle, orbitals are filled induced to increase of energy in the next subshell than the previous. So therefore, the highest energy subshell here is 2p3. And that's the thing that you can use to solve for the quantum numbers. So 2p3, you have n is equal to 2. And then for your L, you have 1. Since L is equivalent to 1. So this is ranging from -1 to +1. So after that, you can already have the arrow. So you need 3. 1, 2, 3. So it stopped to +1. So therefore, your M sub L is equivalent to +1. And the direction of the last arrow is upward. Therefore, the value of MS is equivalent to +1/2. So there you have it. We are done with our discussion. Let us now have your activity. It's now your turn to answer these 2 items. So happy learning. Let us have example number 5. You can now solve for this. You only have 30 seconds because that's easy. Five seconds. Time's up. So let us now solve. N is equal to 3. You have 1, 2, 3. And then for your L, this is ranging from -1 to 1 because your L is 1 because of the P. So -1 to +1. So that's the time that you can have the arrow already. For the orbital diagram, we have 3 here. So 1, 2, 3. Since your last arrow stops at +1, so therefore your ML is +1, and the position, or the direction of the last arrow is going upward, so it is +1/2. So that's it. Let us have now the last example. Example number 6. This one again. 1s2, 2s2, 2p6, 3s2, 3p4. Do not forget the Aufbau principle. So the last or the highest energy subshell here is the 3p4. So you can use the 3p4 for you to solve the quantum numbers. N is equal to 3. 1, 2, 3. L is 1 since it is P. So it's ranging from -1 to +1. So you can now have the orbital diagram. 1, 2, 3. Go back for the downward arrow. 4. The last arrow stops at -1. So therefore, your M sub L is -1. And the direction of the last arrow is downward. So therefore, your MS is -1/2. So see, it's just easy. It is so easy to solve the quantum numbers. So you just need to go back, watch this video again if you have still confusion in your mind. So very good, guys, for those who got it correctly. So thank you everyone again for listening. I am Mom Princess. In order for you to be updated on my video lessons, you may subscribe to my YouTube channel, Mom PM is the Key, and click the bell button. Thank you.